So in our previous video we discussed transistors as switches, and in today's video we will use transistors as amplifiers. So the working principle for a transistor as an amplifier is the same as a transistor as a switch, but the switching is actually not a digital high or a digital low, it's rather instead a changing frequency or a changing signal, which in results allows the gain current to flow to the output. It's all gonna make sense in just a second when we use these three types of transistors for audio amplification. So before we start, I have a feeling that these two BJTs are not supposed to be as good as this Mosfet, because Mosfets are specifically designed for switching very fast and our audio signals are going to reach up to 20 kilohertz. I think this Mosfet is going to do the best, but we will see. So we're going to follow this very basic schematic that you can see on the screen. But before we start, we're going to attach heat sinks to all the transistors, because switching with higher frequencies and supplying higher voltages may actually blow the transistor and may damage our circuit. So instead of using screws, I have added this heat conductive tape on back of this MOSFET, and then we'll attach it to the heat sink just like that. I'm going to bend the base and the collector pin because it won't actually fit in the circuit made for BJTs. Now after adding heat sinks, our transistors are ready to be put in circuits. So we'll just make this circuit very quickly, and then we will just swap all the transistors in the circuit to see the results. So just like that, our circuit is complete. This is our audio in. Power rail of the breadboard is where our power supply is going to go in, and these points are for our speaker. So we will connect our speaker here, then we will connect our power supply, and then our audio input. Now let's see the results. So at 5 volts it's about stable sound. Now we can mess up with the filter here to see if there's any changes in the audio quality. So definitely if I increase the resistance here, the audio starts getting really distorted. So with the BJT it's not that loud, but it's still something. And first I'm just gonna see if this heatsink has really heated up. Well, it's not that much heated, but it still is pretty warm. BJTs actually do work as audio amplifiers, but I won't recommend it because with just a few seconds of testing it, it got really warm, and there are a lot of power losses with BJTs. Now I'm just going to hook this BD139 here and see if it gives any promising results. So now I've put BD139 and the audio here is pretty bad. So here's the result of BD139, and I've swapped the pins according to the data sheet, and this thing is really getting hot, and I think it's not very useful in case of this 74 watt speaker. Now I have inserted the mighty MOSFET here, and first I'm gonna set the voltage to 5 volts, and then we will mess with the gain, but let me just play the audio first. Wow, it's really getting loud here. So when I increase the gain too much, it starts getting distorted. So I'm just gonna swap this for 70 microfarads with a much larger 1000 microfarads capacitor, and then we will see if we get any promising results. So I've closed the door because this thing gets really loud. You see, with 5 volts the gain was not working very well, but when I increase the voltage to about 12 volts or like 15 or 16 volts, the thing gets really loud. Never really saw you come in. Without any distortion. my god, this is just the thing is burning. Okay, let me just pull it out with the wire here. So this thing is so hot that you can't touch it with your bare fingers. MOSFET actually does work as a very good audio amplifier, but the problem here is that you need a proper cooling system for this stuff, because this MOSFET is now so hot that you cannot touch it with your bare fingers. So that's it for today, guys. Thank you so much for watching, and we will see you next week.